you could do it. You just you really did. Good, right? That's why the eyes
Yeah, so the data that they generate. So as a physician, you not leave.
Co-founder of OpenM Health and a professor of medicine here, and
I'm John Duke, visiting from Georgia Tech. I direct the Center for Health Analytics and Genetics on there.
Excuse me, my name is Eric Claus. I am actually a contractor and kind of a local expert on the FHIR health data standard.
And on the computer here we have Eric Soto. Eric, you want to introduce yourself?
Hi, this is Eric Soto. I work with John Duke at Georgia Tech and helping out everybody with the OpenM Health project.
Great. Shall we go around and just introduce yourself and what you're working on and what brings you?
Sure. I'm Jacqueline Bagwell. I'm a clinical research informaticist for the Research Triangle Institute, and I do a lot of work with the ONC. Currently, we're working with them to develop a health IT infrastructure for research, and we'll incorporate the OpenM Health standards, hopefully.
Great.
I'm Stuart Reynolds. I work for Physioscience in Mountain View, and we're working with hospitals in China to help people understand their population health and
I'm Jeff. I'm a primary care pediatrician at Stanford, and I also work at the Department of Public Health on some mHealth solutions around pre-exposure prophylaxis for HIV and adherence.
And I'm Michael. I used to work at the Office of Innovation, Technology and Alliances at UCSF, and also used to work at a wearables company.
I'm Matt, and I'm with Mike here from Mount Sinai, and we're looking just exploring OpenM Health and how we could apply that to N-of-1 studies.
Oh, wow. Are you with Node Health at all?
No.
No, but we heard that name from our boss today.
It's a group that does the evaluation of mHealth work and comes out of Mount Sinai.
Cool.
So I figured if you were there. And you were?
My name's Michael Jones. Also work for Mount Sinai. And just to elaborate on what Matt said, we're working on a mobile application and platform for single patient clinical studies.
Do you know Katrina, what's her last name, at Columbia, who has a large grant doing N-of-1 studies?
I've heard of her, but
Yeah, Katrina Grant, you know her last name. And Rich Kravitz and I just published an article in JAMA Internal Medicine a couple of weeks ago that had the largest N-of-1 study ever, and it didn't work.
Oh.
No, no, we recruited 200 something patients and randomized half of them to N-of-1 for chronic pain management, and the other half didn't use N-of-1. And at the end of it, they were using just as much, opiate pain medicines, and the pain scores maybe were a little better, but weren't really that much better. So it didn't really customize, but people used it, people loved it. I think 85% of the people went through the whole protocol, so it can be done. It just clinically it didn't work out. So, are you guys working in any specific clinical domain on that?
well, right now we have.
Yeah, at the moment, it's kind of a proof of concept, but we're planning to launch the platform with a cognitive study, just comparing the effects of nootropics on cognitive ability.
Okay.
But to begin with, we're looking to study adherence and those things before we get into more specific clinical applications.
We wanted to start with a really low risk study, so that we can basically just
Kick the tires.
and pick something that the general population would be really interested in. Just
getting
caffeine.
past an IRB with a general platform for studies is difficult. This
Let's
is our
talk after,
proving
because I
ground.
have a very, very large project that's very, very low risk
Cool.
on N-of-1 that we need a platform for.
Oh, that would be great.
Yeah, because we had an OpenM Health platform, but OpenM Health is now much more about standards and less about platforms, and so we've been looking for an N-of-1. And so we're going to talk after this. Great. How many are developers in here? Okay, good. I'm glad you put your hand up. should we, let me go find out that, you know, lots of people signed up, but I know it's been hard. Was the traffic horrible or something? I think there were lots of people having trouble, I think, getting from downtown. But let me go.
Hey guys, my name is David Dad. I'm the executive director of O&M Health and as well as CEO of Overlap Health, which is kind of it's a for-profit company that's built on top of the O&M Health standard and tools. We have an exciting meeting today. I could talk a little bit about the overview and just, you know, yeah, we have an exciting meeting today. We have some great guest speakers, but I thought maybe just taking a step back, you know, we haven't talked to you guys in a while, so I wanted to just, you know, say thank you for coming. I know it's been a while since we've had a meetup, some new faces in the community and whatnot. We've been up to some really kind of big things, specifically with the IEEE, as well as this collaboration with the FHIR community to kind of bridge the gaps between mobile and EHR, the EHR worlds. And so we're excited, and we're also looking for a community manager. Just some housekeeping. So if anyone's interested or knows someone that has some maybe technical skills and wants to kind of do more of these types of events, please, you know, come see me afterwards or email me at david@overlaphealth.com, openmhealth.org, and saying that one a lot. Please, just let me know. So we're here today because we're in a really different time right now. It's a changing time. Who's been following some of the new MACRA kind of quality payment changes that are going on in the government and payment reform? Yeah, not too many. So are you guys familiar with what's going on with shifting from volume-based care to value-based care? Yeah, so that's a big deal. And so what's going on now, the government has been trying to incentivize providers to deliver better value and better quality care to patients. As part of this new movement, a lot of the quality criteria is to be able to have patient-generated data as part of the record and as part of that transformation in quality improvement. So this is a very unique time because we're now trying to get mobile health, which is a mechanism and a tool to be able to get the patient-generated data and connect it with the clinical world. So we're going to talk a little bit about some of the things that we've done with the FHIR community, as well as show you a really cool demo. We have a little agenda over there on the other side of the room if you guys can keep track. But it's in a very exciting time. We're seeing this happening more and more. Providers that are trying to bring this data into their record. They're trying to figure out how to display it, how to make it actionable and meaningful, and not to mention they want to use standards as much as possible to make that happen, whether it's FHIR or using Smart on FHIR to make that happen. And they're looking for the mobile health standards to be able to get the patient-generated data in there. So without further ado, Ida, do you want to take it away? Sure.
So to set the context for the demo and our discussion, I thought we'd go over a use case. I'm a primary care doc, so this would be one straight out of my practice. A patient with moderate cardiovascular risk, maybe they have high blood pressure, maybe they have high cholesterol, and they're looking to try and reduce their cardiovascular risk. And of course, we know from the American Heart Association, from the CDC, we're all supposed to not sit on our butts, but supposed to be moving. 150 minutes of moderate activity per week, and that's a lot. It's a lot. And this patient said, "Doc, that's a lot." So a joint discussion about what is an appropriate goal, right? So maybe this person says, let me try and get 4,000 steps per day. Maybe that's as much as they're going to go for, which is good because you want something that's achievable. And so after the joint goal setting, there could be a process of what we call data prescription, where the person gets a device that helps them to measure their steps, and also the physician orders the step count in the record, right? Just like I order, take a blood pressure pill every day, or I should just be able to order track your steps. I actually do this now. I tell people to track their blood pressures and bring in their results, right, or their blood glucose. So it's very similar. There's nothing special or new about this at all. But how do you integrate it into the workflow? And for the patient then who has that wearable, they have their their app on their phone, right? The wearables that's talking to the phone and then talking up to the cloud. And, you know, the idea here is, you know, 3 months later, the patient comes back to see their primary care doc, and they do a joint data review at that time, okay? And the doc hasn't been bothered at all with any information, because really clinically, I'm not going to be doing anything about, you know, whether he's gotten to 3,000, 4,000 steps or not. But we do want to sit down and look at the data together. But what I do not want to do is sit down and have to like launch up a new website or sign in somewhere else or figure out, you know, how to authenticate and get a login and get him to log in and, like, you know, that all that kind of stuff is just it's a no-go for how clinicians would work. So the idea here then is to have a window that kind of floats within the EHR, right? So I'm in the encounter for the patient already, so I know this is the patient looking at his chart already, and I have a way of opening up a window which then displays information from the sensor and the app. And of course, this, you know, this being Epic in the back, this is not an Epic display, right? It is within Epic, but it's not of Epic. And in fact, the data doesn't have to go into the Epic EHR at all, which is good because many hospitals don't want people writing into the EHR database, but it can still, you know, be visible to me as a clinician in my workflow to do the kind of care that I need to do, right? So this whole process of getting something, you know, into the workflow in this way uses FHIR, also uses Smart on FHIR, and because we're doing OpenM Health, the data that comes out of the wearable is going to be in OpenM Health standards, and how do we bridge the wearable data in the OpenM Health data standard, get it into FHIR, and have it show up in the dashboard, okay? So that's the sort of the underlying process, and of course, once you do it for that, you can do it for any other kind of mHealth data and get it into the clinical workflow. Okay. Any questions about this? So we'll go on to Simona Carini. Actually, Simona, you want to just introduce yourself? Everybody else did already, so you can.
Oh, hi. So I'm a data scientist for OpenM Health. My background is in nursing, clinical trials, and mobile health. So I will focus for a second on the part that I have highlighted. So the idea is that the patient is gonna have whatever device they have, and how do we make sure that that data is captured in a way that everything that happens here can happen regardless of what the sensor the person uses. So the idea is that then different vendors, different devices define their data in different ways. And that makes what we saw in the previous slide difficult. So in an ideal world, we all talked the same language. So we agree on how to represent the data and what's the meaning of the data, so that regardless of what device the person is using, then on this end, there is an ability to visualize the data. So we're using step count as an example, which is, it's not particularly difficult in the sense that the number of steps, there's not many ways of representing that. But if you can think about other data, then things get a bit more complicated. Sleep, for example, blood glucose, etc. So the idea is that, OpenM Health is worked on schemas. And schemas are ways of representing the data in which we agree what the units of measure are, what are we measuring, what does it mean, and what are the context information that are important in order to interpret the data. Again, the example that we usually use, both blood pressure and blood glucose, for example, a measurement of blood glucose, an important piece of context information is the meal when the person had a meal. In the context, for example, of steps, we know that the physician here doesn't want to look at every day from a person, because that would be an enormous amount. That would be like in 3 months would be 90 different. The physician is interested in looking at summary information, like the average week or the average month, or is this person moving more, so there is a trend. So the schema represents not only individual measurements, but also what we call descriptive statistics. And so here is an example of what OpenM Health compliant data look like. So in the example on the left shows just a simple measurement. It's a count of steps within a specific time interval. But then, instead on the right, we have something a bit different. So the time interval is a month, and the step count, I know it's high, but it's an average. So whereas this is just, it's the number of steps within a time interval, this is an average within this time interval. And then, of course, average over, you have to say over what, and this is the daily average. So this is more like the kind of information that a physician would like to use. And again, the schema, I'm not going via the detail, but the schema provides a way of a way of describing this information that it's standard, and so that regardless of what the device the person is using, then on the receiving end, the display can display the results. So to answer, in summary, to answer the use case, the schema has a number of properties. There is the step count, of course, and we all agree it's a number. Then the time frame over which this measurement is effective, and that's a time interval. And then descriptive statistics and the denominator, those are values from a value set that it's agreed upon. And then in case that's important to answer the case of the moderate intensity that's measured using MET. So this is sort of in brief why we need standards, both for the data and also metadata. Metadata has to do with, learning, encoding what the device that recorded the data, when the data was created, the user, the privacy, all that kind of information that it's data about the data. And so that's necessary because, again, there's there are multiple devices out there, and we want to make sure that the data from these multiple devices can be pulled together and visualized in a way that it's is standard, and that will help both in the clinical care and also in clinical trials. So OpenM Health schemas, they were developed using some design principles. And each data point includes a header that contains the metadata that I just described. And then the body of the data point, examples of which I provided in the previous slide. And also for ease of use, we try to annotate to standard vocabulary. You will hear this is also something that FHIR does. So that, for example, this is an example from sleep duration that it's annotated to SNOMED. And again, using units of measure that are standard using UCOM. This is an example of a header, again, a set of metadata, when the data point was created, to which schema which schema it complies with. In this case, is a physical activity. And then some information about the acquisition. In this case, the data point was recorded using Runkeeper. It was created that, and the ID, and then the modality. This was sensed, because in some cases the user can also manually record some information, and the user ID to which this data point belongs. So until all the situation right now is not that is not such that all the device makers generate data that is OpenM Health compliant. So OpenM Health has created a tool called FHIR that contains libraries called shims that take, using provided APIs, take data that is from one of these providers, and you will see the example with Google Fit, but also others, and take the data and then transforms that in so-called OpenM Health compliant data. And this, again, this is to show that then, regardless of where what the device that originally recorded the data, regardless of what it is, then in the end, if all the data is OpenM Health compliant, then the data can be pulled together and, for example, visualized or otherwise analyzed. So in summary, the idea is to standardize mobile health data and metadata, helps with data aggregation, and then helps with the use of mobile health data in clinical care and also clinical trials. And so OpenM Health work has been in providing clear semantics using index to standard vocabularies for optimizing data for this use cases. And FHIR is an open source tool that is actually available to the community that takes data from certain providers and generates OpenM Health compliant data. And then our community is growing, and you will hear after me Eric talk about the FHIR implementation guide. We also have worked within the context of IEEE working group that works on creating mobile health standards. And I provided some links for your use. And now it's Eric. Yes, I was about to, any questions?
Yeah, I mean, I'm actually very happy to see the use of the term metadata in here, because there are at least 7 dimensions that I'm aware of that are really kind of important metadata elements that in some way will allow clinical users to have faith in these data, which actually then also allows, I mean, I actually provide input to CMS around the use of patient-generated health data. And so I'm wondering if some of these elements, I mean, some of them have to do just with the device, the firmware version, things like consistency, accuracy, precision, authenticity. I mean, I can name all 7, but how many of those types of things is OpenM Health trying to capture? How many of those types of things are manufacturers willing to participate in providing as a standard?
Okay, so I'm gonna try and address this, and Ida can also add. So there's certain things that validation is a different thing, and so that's totally currently outside, because validation is something that is provided, it's done by the manufacturer. So, but what the metadata should have information about various, as you say, various dimensions. Now, within the context of our IEEE work, we're actually starting to discuss this, and we're prioritizing exactly for that reason that there are so many. And so metadata about the data point, about the creation of the data point, about what the schema is to which the data point complies, those were deemed higher priority, and we're working on that. We're also part of a project called MProv, which is funded by NSF, that talks in particular about provenance and tries to address all this that has to do with the algorithm and all the processing through which the data went through. So it's a work in progress, because you mentioned 7 dimensions, so it's complicated. Part of it is also how much of this travels with the data point itself, so that you have a small data point with all this information about the data point. So we're looking also at ways of capturing this information and storing it, but in a way that it's efficient so that it doesn't have to travel with the small data point. I hope I address.
I mean, absolutely critical issue, and I think need to be pragmatic to get enough of a metadata standard so that things can work without overloading it, because metadata is hard for people to, generate and describe. So our approach, as Simona said, through the IEEE process, because we are working towards being an IEEE standard, prioritizing the data and the schema, and then acquisition provenance is what the group has decided that were the highest priority. Processing provenance, the algorithm that actually generated, that kind of fell off. Privacy fell off, and context fell off into a sort of second tier. So focusing on acquisition provenance and on sort of the data and the schema, working with the FDA and other groups on thinking through what is a minimum set of metadata standards that can then be used, in the regulatory space and then in the clinical space as well too. So we'll be talking about that, and we should get back and see what's going on at CMS, because the federal agencies need to get together on this. And of course, HL7 has a lot of work on provenance as well. But it's sort of like, it's a big, heavy model, and, so it's really, what's that sweet spot? And so we're working towards a sweet spot to get something useful. Eric, you want to say something?
Well, many times we're talking about unregulated devices, so you're asking a lot out of something that's been basically a commercial device you get off eBay for $30. I'm not sure what's appropriate in that case. I don't know.
Yeah, and it may not be, but I think having a sort of a minimal, lightweight, but hopefully valuable metadata standard for people to work towards, is a start. And I'm sure many devices won't
Well, the
get to
question
actually
of the
use it.
regulation too is coming, because there's the pre-certification program, FDA pre-cert program that 10 large organizations are participating in right now, but that'll probably end up defining the landscape for what devices will in fact need to be regulated, and software as a medical device, that's coming.
But with a lot of the devices also kind of consolidating, the ones that are the bigger ones are actually all they're advancing the metadata that they're providing in the APIs as they're sending the data over, and we're seeing that in some of the work that we're doing at Overlap. But it does, and I think OpenM Health is helping facilitate some of the basic stuff like acquisition and whatnot. But the fringe devices, the ones that are dying out are. I don't know. Maybe it's not.
Yeah, it's an evolving ecosystem, but the regulatory agencies do need to put a stake down and say this is the metadata that we care about, and then work with other agencies and other groups, public-private partnerships, so that those who want to move forward in metadata, there's some sort of coherent path forward for all of us together. That's really the strategy that we're using in OpenM Health.
I'm going to talk a little bit about FHIR, introduction to FHIR, and how we're merging the two standards to create some useful ways to get patient-generated data into as Ida talked about, getting it in front of the provider's eyeballs, as well as patient eyeballs too. Okay, so. So what is FHIR? Well, first of all, FHIR has been developed by an organization called HL7, which is another standards organization. It's been around for a while. Been in the business of meeting challenges of data standards in healthcare for over 20 years. And we've produced at HL7 a couple standards, 3, probably I can count 3 that are major standards. There's something called version 2, messaging standard. There's something called CDA, which is a document-based, you exchange documents in a standardized way. And there's something called version 3. FHIR came about like 2012. It's based more on emergency industry approaches that we all know and love from Google, or not love, from Google and Amazon and those types. So FHIR is the newest kid in the block, and it's created a lot of buzz. And so what makes FHIR different? Well, first of all, it's a much stronger focus on implementation versus modeling. Some of the prior standards are more modeling focused and very difficult to understand. So we tried to make it fast and easy to implement. It's tough to have a very broad standard in healthcare and have it fast and easy. We're doing our best. It uses widely used RESTful practices and web standards to make it more accessible to developers. And we try to focus on having implementation libraries and reference implementations as we're building, as we're developing, so we always have those pieces of the puzzle current and ready to be used by developers as we move forward. And we're just trying to basically kickstart development and build a community around FHIR. So we're trying to provide all the tools that we can so we can keep the momentum going. So there's several important pieces of FHIR. I'm just going to talk at a very high level, talk about a few of the primary components. First of all, Simona talked about schemas. We have something very similar to schemas. It's actually equivalent. They're called FHIR resources. FHIR is based on a resource, which is a common building block of our content model. It's a model. You can call it a schema. Our models are more generalized. We take most of our models, well, many of our models are very generalized. We have resources that deal just with the infrastructural components of interoperability. I forgot to mention that. HL7 is really focused on interoperability. So getting information from point P to point B to point A or B, and having that interface, that interoperable interface where you can take it from one system, one organization, and hand it over to another organization in a common language. So that's really what FHIR's primary focus is on, interoperability, although it's kind of a little broader than that. It's actually evolved to be much broader than that, actually. So we talk about metadata in our OFFIR resources. We have metadata. We have a set of defined elements for each kind of resource we have. Like I said, we have infrastructural resources. We have resources that just focus on terminology. There are resources, clinical resources, or resources are observations, conditions, pharmacy resources like prescriptions or medications. So we have resources that describe or represent things, medications, devices, and then there's a lot of other specialized resources that go. And we have about 120 or 130 or so resources. New ones being proposed all the time, and so I expect to see more as we continue to grow. When we talk about these content models, they're very flexible. They can be constrained, they can be extended. Extensibility is a concept where you have a particular use case, because we try to capture the 80% in the FHIR standard. Then there's always going to be a use case or a specialty or speciality that you need to add to the resource. We have mechanisms in the model to allow that. And so we have a FHIR model, and when it's being actually implemented over the wire, then we support or describe in the specification itself. We actually specify or describe in great detail how to represent that over the wire in JSON. That should be XML. That was a typo. XML. There's an RDF representation too. So we're trying to make this as implementer, developer friendly as we can. Here's just an example. There's a JSON example of a resource called observation. This is actually very similar to IDA's schema. We just mapped over all the elements over to a zipped up and moved over the wire to another partner as a receiver. The second major component of FHIR would be the RESTful API. Although not required, FHIR specification is agnostic to how the content models are used. We have a pretty robust API using the RESTful paradigm, and in REST we define a set of common interactions such as reading, updating, searching, a lot of things that you would do. For example, if you're on your web and Googling, you would do a GET, basically very similar to that. So the RESTful API is probably the most developed and most commonly used a part of FHIR when interchanging information between partners or searching or writing to an endpoint. So those are the two major pieces of FHIR. We have a set of resources, and then we have a RESTful API, a way to interchange the data. And I just want to mention terminology. Since FHIR is a broad approach to healthcare, there's always a pretty strong approach to terminology in FHIR. So it's such a strong emphasis. We have several resources just devoted just to terminology. So we just define a value set definition. We have a definition for a code system. And we have actually server definitions for terminology services and so forth. So, so if you get involved at all in FHIR, you'll see there's a strong emphasis on the terminology aspect, a lot of codes and coding in medical terminology. So I kind of added that to the two main core pieces of FHIR, because I think that's an important part. I think that FHIR does medical terminology really well. In ways of representing the terminology in FHIR, I think FHIR does the best job, as far as I've seen, in helping make terminology useful in a standard. Okay, there's a lot of other capabilities that FHIR has. I've touched on the very basics, but we talk about operations, there's messaging, classic messaging sent. These are just architectural ways to transact and represent data and interchange data. So we talk about messaging documents. There's even asynchronous protocols defined, something called GraphQL, and even talking about using the FHIR resources as a persistence data model. So there's quite a bit going on in FHIR. It's pretty broad. And the best way to get a better view, besides me sitting here talking for 10 minutes, I'm just going to scratch the very surface, is to check it out. We have the official published version right now is release 3. We're going to be coming out with a new version called release 4 in January, and in that particular version we'll have actually certain parts of the standard will become normative. In other words, they're not going to be changing. So that's kind of a bugaboo when you have your standard keeps changing. There's other parts that are still in draft and will be changing or may change in the future. But so here's the website where you can look at get more information about FHIR. I talked a little about versions. There's several versions of FHIR, so you always have to be aware of what version you're talking about. And I just have a list here, and I forgot to add a link here. But here's a lot of places where you can grab more information on FHIR. There's sections on getting started, the resource index. We can look at the different resources that are covered in FHIR. And then there's a lot of documentation and a lot of supports for tools like reference implementations or standard libraries to try to interact and play with FHIR. Okay, so the next step in getting more involved in FHIR or learning more about FHIR is basically read the spec, look at those links. There's a growing FHIR community, just like there is for OMH. And we have a Zulip chat called chat.phir.org. It's a very active community. If you have any questions about FHIR, feel free to sign up for that and ask. There's a constant stream of information going. And that's a good place to get started. Read the spec, and if you have questions, you can always ask on the chat line. Okay, so how are we integrating OMH, or how are we marrying the OMH schemas and the FHIR specification together? Well, first of all, just to look at and compare them, both have content models. FHIR, we call them schemas, and OMH are called, in OMH they're called schemas, we call them resources. The OMH content models are really focused on patient mobile health data, generated data. So they tend to be a lot easier, a lot more lighter, and when I first looked at them, I said, they're so easy, where's all this other stuff? But then I realized that you don't need that other stuff. In the FHIR resources, you have a generalized model, so it contains a lot more stuff, and it can get a little bit overwhelming. So I think that one of the nice things about the OMH stuff is it's really kind of lightweight. It's kind of nice to work with. OMH uses JSON schema for content modeling. Like I said, in FHIR we have several different ways you can do that. We do have JSON schemas in FHIR as well. And then, but FHIR does provide a robust API framework, which we're going to show in a few minutes how we're taking advantage of the FHIR RESTful API to help provide access to some of the OMH generated data. And of course, we can map OMH content to a FHIR content model. We can go from a schema to a resource. And so we actually created an open MHELP to FHIR implementation guide that kind of describes the use case and how it's done, and also looks at the mapping between the two content models. So here's just a screenshot of the open MHELP to FHIR implementation guide. There's a link up here. And so we're going to, in a little demonstration model, we're going to show the little workflow that Ida talked about, where you have floating on top of your screen, as a provider, you can see the summary data from the step count that you've ordered. And so basically, we have this, I'll call it a smart app workflow that we describe in the guide, EHR to this OMH to FHIR server, which John's going to talk about in a little bit, and it's going to pick up the patient-generated data, and it's going to zip it up and send it right back to the provider to take a look at. Okay. And in this workflow, we're talking about using FHIR, we can actually, and Shimmer and all the tools we talked about, retrieve OMH data and retrieve it and display it and use it in its native OMH schema format and do something cool with it, make a nice pretty graph or something. We can also, in the guide, we talk about retrieving that OMH data and mapping it to FHIR and using the FHIR observations and using that information as a FHIR resource. In that case, we're going to be talking, and in this OMH to FHIR server, we have a little step that maps the OMH data that's been generated to FHIR. So I talk about smart. Why did I say smart? Well, the smart app workflow is because there's another piece of the puzzle here called the Smart App Launch Framework, which helps connect third-party applications to EHR data, and it basically helps with the authentication. It's based on OAuth 2 authorization protocol. And if you have any more questions about Smart, I encourage you to check it out. Or if you have specific questions that you want to ask answered here, I'd also recommend you ask John, because I'm not a smart expert, he is. So I'm not that smart. Okay, and then the final piece of the implementation guide, it talks about the use case, it talks about the workflow, the smart app workflow. We also talk about mapping, how we map, and there's actually a conceptual mapping in the implementation guide. But then we want to talk about, we also have some real practical mapping. So mapping OMH to FHIR. What does mapping mean? It means you take, in this, you can't see this, but over here is the schema, an OMH schema, and over here is the FHIR resource. So the data elements in each one of these can be represented, and you just have to kind of rearrange the pieces. And in some cases, you map directly over from OMH to a FHIR observation. In other cases, we have to have mapping translation tables where we have to, insert codes or units based on the schema or based on some of the data elements within the guide, within the OMH schema. So, so the guide is basically covering the mappings. It covers the workflow, the use case, and gives guidance on what we're going to see here in a few minutes. And then I'm going to skip this slide, and we're going to prepare for a demo. And I went over it very quickly, and I went over it at a high level, but if anybody has any questions, I can take a few minutes to answer them now. There's nothing to say. Okay, you have nothing to show?
Oh, I do. I just want to wait for any questions.
Okay. You have nothing to show? Yeah. Okay. Well, thank you.
And this is a design of the instantiation or implementation of OpenM Health on FHIR that Eric Soto, who's on the phone there, architected, and that we sort of put together, but using all the pieces that we've discussed. So if we can sort of mentally map the use case that I had described at the beginning, and then we'll talk about some of the pieces that Simona mentioned and what Eric just mentioned, and it should all kind of come together. So the story that we had, you may recall, was a physician recommends someone start tracking their steps, and then they're going to follow them up at a visit, and they want to check and see are they getting their daily 4,000 step target. So that's kind of the general idea. So this side of the equation is basically the EHR. So Smart on FHIR, which Eric referenced, is kind of a framework for launching an app from an EHR. And if you're sort of logged in as a provider, Smart knows who you are. If you're have selected a patient, it knows the patient context, and you can basically launch an app, and you tell that app who the patient is, who the provider is, and it can just do things. So in this particular case, this whole thing in the middle, the OpenM Health on FHIR server, it can live anywhere. It can just be up on Amazon, it can be on a server at the hospital or health system, and it's got a few components. One is basically like a web app, and that web app basically gets launched. It's sort of registered with the FHIR server and Smart on FHIR server that's part of this EHR, and it gets launched and it says, okay, who is this doctor or who's the user? Are they authenticated? Who's the patient? And it learns basically what is the context that I'm being asked. Our particular app is to go out and get data about a mobile device. The way that that does it is what Simona described. There's something called Shimmer, the Shimmer APIs and the shims that connect to these different device APIs. And this app basically says, okay, I have a patient, go and get me the data on that patient. In order to do that, it basically first checks and says, have I registered this patient before? Do I know what devices they have? Do I have any pre-existing information? If not, I need to authenticate them against the devices. So I have a patient ID in an EHR. I have a Fitbit ID and a user, and I need to kind of link them together. So this is sort of where that basically happens. And then it just flows real time. It goes, it grabs the data, it comes back, and it can deliver it in a couple different ways. And we'll see how it does that. It can deliver it as a document OpenM health form or as a FHIR resource, as Eric described. So let's take a look and see how that works. And I'll start with the, let me just show the whole thing here. So first off, in this particular case, I'm launching an app, but I haven't. So I'm a physician. I've sort of registered. I'm in an EHR, but I haven't picked my patient. Normally, you would have already been typically in a patient context, but in this particular case, we are not. So the flow, and I'll just go ahead and sort of show these a little bit side by side, is that I'll pick a patient. I'm going to pick somebody that we have not registered yet, hopefully. And it's going to say, okay, let's connect this person to an account. And so, oops, there's a patient who we've already picked. So that's fine for showing a patient that pre-exists. Let me just go further down the list so you can have the experience of authenticating somebody new. All right, let me just go. Okay, so we'll just pick someone random and see here. All right. All right, so basically, I picked a random patient who I had not used as a test previously, and it basically says, okay, I clicked I want to connect them to Google Fit, and it wants me to authenticate, and I can authenticate as me, John Duke, but I think we also have an OpenM Health user that I'm going to use. Not that my personal exercise data is that crazy, but so this basically asks the kinds of things you would expect. So this is now doing an authentication. Anyone who's built a web app integrating with an API with authentication knows that it asks permissions and things like that. So we basically said, we're in this Smart on FHIR or OpenM Health on FHIR app. We say we want to connect to Google Fit. It says, okay, who's the person? I put in my ID, and then it's going to say, are you willing to let this app use your data? And we appreciate that Google asked that. It says, okay, you've successfully linked. And I think it's, and basically, this begins sort of these couple different workflows that we have and described before. So the first workflow, what we're going to do is we're going to just say we want to pull data back as native OpenM Health content. And we can set dates and things like that if we want to do last month or whatever we want to do is fine. This is maybe the last couple weeks. So I'm going to pull the data back as OpenM Health content. And so what this does here, and I'll put it in JSON lint so it's easier to read. And what you see basically is that it has returned a few things here as a FHIR resource, but as a resource called document reference. So you can imagine that most of what we're seeing from a Fitbit is an observation resource. So FHIR has lots of resources, and Eric didn't name every single one of them. There's quite a few, but one of the most common ones is observation. That could be a blood pressure, that could be a physical finding or observation, or it could be a Fitbit reading. But in this case, we're saying there's a document which is a bundle of OpenM Health formatted data, and we just want to reference it. So it returns a very simple set of information. And it just says, here's a binary that's JSON formatted, that contains the OpenM Health data for this patient. And to look at that binary, it just sort of looks like this, which is, here, I'll blow it up a little bit, but basically, this is the type of information that Simona had described before, where it has the header, it has the provenance, it has the schema, being OpenM Health, it's step count, it has the information there, it has the time frame, the body, so all the pieces that Simona described are being returned by this application, and essentially it's just saying, here's the start date, here's the end date, here's the step count. This is not FHIR, this is OpenM Health. It's the OpenM Health schema, but it's bundled up and it's passed in as a document with a URL that FHIR is sending back and saying, if you want the patient's data, here it is, it's OpenM Health, but you can go and get it. And so that's what this application in the first version has done. It basically says, okay, I'm going to take this, and it's now demonstrated using the OpenM Health data, just sort of a graph and a visual that we can play with and whatnot, of this patient's step data over time. So this is essentially sort of the aggregated data, as well as sort of a breakdown of the counts as they've come in. As Simona referenced, you can get step counts with high frequency, or you can get them aggregated. So in this particular case, we're using FHIR as like just a transport mechanism for OpenM Health. The second use case, similar, and maybe, which is to do the same thing, but to look at the data as actual FHIR resource. So in this case, I think distinct from what we saw before is that the resource type, I'll blow it up here, the resource type is now an observation. So where before we had a document reference pointing to an OpenM Health resource, now we have an observation, and it's basically, as exactly in Eric's discussion, it references an OpenM Health system, the code system, but when you go down, it has a LOINC code, and it has a name for that LOINC code, which is the number of steps over a period of time in a pedometer. It has an effective period. So it's rendering the information in the FHIR format for an observation. So it's now basically returning. So if we were to go and say we want to do a query without having an app. So we've created an app to go and visualize the data. But you could also say, I just want to hit the FHIR server and get the patient's step counts, and I want to use it for something else. This would be the pathway that you might prefer to do that, because it basically returns it as an observation along with blood pressures, along with things from other sources. It's not really dependent on the particular, just being OpenM Health. It's just a general FHIR observation. So this is the way that the data would come back, and it's much more, it's just much longer. It's all of the observations are now. So you can see, I don't know if you can see my little cursor over here, but oops, sorry about that. But there's a lot of data here because all of the observations that were in OpenM Health before are now rendered in FHIR. So just as a overall overview, what we basically have done is we've retrieved the same data in two different ways. We've done it live from the APIs from Google Fit in this case. If we were to go back and pick a patient who's already registered, it goes right through. If you pick a new patient or we change the person, of course it brings in different data, but it's using that API and it's basically passing through that OpenM Health server in order to serve it up as we've described. So I will pause there, ask if there's any questions about how that works or what we just did or what we're trying to do. Yeah.
How do you aggregate data from different devices? Because right now all I see are devices associated with Fitbit and things like that. So you talked about blood pressure, for example, as part of another data point. How does all that come together as part of this whole OMH and FHIR?
Yeah, that's a great question. So if you were to have, so say you had a device, a blood pressure, like another blood pressure device, and then you had the pedometer and some other things. So all of those would come back in the FHIR version. They would come back but with different LOINC codes. So one would have the blood pressure LOINC code, one would have the pedometer step count LOINC code. And just like any other application, you might say, I want to go get all the patient's blood pressures. And the system wouldn't really know other than you've given it a LOINC code or set of LOINC codes, and it retrieves the blood pressures, and then you could display a visual, or you could do some sort of cardiovascular risk graph or something like that. So in this case, it actually is treating each data point somewhat individually. It's served up from the device through OpenM Health, but the blood pressure ones are mapped to blood pressure link, the pedometer to the other. So it doesn't actually know, in a sense, that what's what. It only knows what you're looking for. So if you ask for all observations, it would return everything, including things that were recorded by the doctor, in the office or something like that.
So if I want to do some correlation in terms of, how do the number of steps impact, for example, blood pressure.
Yes.
I would have to do that separately outside this through an app and pull the data and do the correlation.
So you would do the same thing in terms of pulling the data, but then how you would treat those data, you would create separately. So the logic of how I want to visualize it, or how I want to look at blood pressure, or do some sort of analytics, statistics, or something like that, that you would do separately. This would be just to retrieve those data. But the nice thing is it works across all of these different devices and all of the different EHRs. So really, it's just your end application that you customize.
Can I add one? So the other thing with in the same way, OpenM Health Shimmer is also, you can add, it's open source, so you can add whatever you want to, whatever data type you want to it. So it spits it out in the OpenM Health format, which allows this to happen too. So you can add as much as you want into the whichever side you're coming from. Yeah.
Eric, did you have a question or a comment?
This is Eric Soto. I was just going to add, in terms of knowing what data you're getting, the OMH on FHIR application is talking to the Shimmer API, and so Shimmer exposes a number of APIs that you call to request certain types of data. So in our case, we're requesting the step count data, but if you wanted to get heart rate, then you could call the endpoint for heart rate, or if you wanted to get body weight or height, then you would call those specific APIs. So there, you can request specific types of data in that way. You're not just getting every single observation that you have. In our case, we're returning observations for step count.
And in either case, it could be either an observation or the native OMH schema format can be retrieved, whether it's a
Yes.
heart rate or
Right.
or a step count. So
Right. Yes, exactly. If you have applications that are built to work directly against the OMH native schema, you can just retrieve that and go directly from there. Exactly.
I mean, the reason I ask is, we have, sorry it's late, so we have an app to look at risk profiles for people. For that, I would need to get a lot more than just step count. So I'm trying to understand, by using different API interfaces from Shimmer, I'm able to pull different types of data, whether it is, blood pressure, or whether it is, other data points that are critical to assess the risk factors. So I would have to conform to the standards associated with the OMH on FHIR, right, to be able to leverage whatever app I've got, which is essentially a user interface that pulls all this, aggregates all this information.
So you would need to conform to the FHIR. So say you went the FHIR route, you would need to conform to the FHIR standard. So whether it's from OpenM Health or not, it would really just be the FHIR results. But you, for example, could retrieve cholesterol levels, just as well as you could retrieve step counts or blood pressures. So you could use any of the FHIR resources to use in that calculation.
The benefit right now of OpenM Health is for the devices that you see here, primarily physical activity type of schemas, sleep, blood glucose, blood pressure, heart rate. It's not all the data elements, of course, but it's just a beginning set that you can pull in. And the idea is that once you have the data coming in OpenM Health format, then you're device agnostic. That's the whole point, is so that you can get device agnostic. If you don't care to be device agnostic, then you can just build to whatever you're going to build to, right? But that's what we're trying to do, is to promote this ecosystem where you can build once, so you can pull in data here. You have your decision support algorithm to provide the kind of decision support you need, and then it doesn't really matter what's coming in here, because as far as you're concerned, it's all going to come in exactly the same way. That's kind of what we're trying to get to. Yeah.
I was going to say, we did talk about, Simona talked about aggregating data at the device level, but you can aggregate data here in the the middle box here, I mentioned, it's not implemented here, but you could do all kinds of, calculations in that middle step and just aggregate your data there too. That's an
Yeah.
option that we never.
And you can aggregate,
At
you
the
can-
client level, yeah.
You can aggregate anywhere, and you can have data coming in OpenM health format and non-OpenM health format. You can have data going out in OpenM health format or in FHIR format. What we're trying to do is to build that bridge, because as we looked through the whole ecosystem and looked at what people were doing, there was no one pathway that everyone was using, but that people are wanting to, cross paths. And so that's what we're trying to do here, is to build that cross-link so that everyone can sort of find the best approach that's right for them.
So have you thought much about the different types of device data? I think all the things on the right are really kind of point-in-time types of data, but increasingly we're seeing things like EKG devices, which is more like a time series, or imaging, take a picture of your mole, or stethoscopes, audio data, and all is available as in mobile devices. So I think each of those may need a different kind of treatment with the kind of data that you're receiving, in the sense that they're not a single point in time, right? Have you thought much about this?
Yeah, so I think there's a big distinction between data streams
Right. Yeah.
and derived data.
Right.
And the modeling of data streams gets challenging. And I think the use case is different, right? The data consumers that are consuming data streams are doing different things with those data streams than users that are consuming sort of the derived data. So we're trying to solve the derived data use case first. I think it's easier, and it's also closer to what the clinician needs, which is the derived biomarker, the digital biomarker, rather than the whole raw data stream, because it needs to get processed at some point. And so that's why we're starting really with the derived data. The MPROV project that Simona mentioned does deal with data streams in particular. We're also part of the NIH Mobile Data to Knowledge Center, a big NIH Center of Excellence in Mobile Health that also focuses on data streams. So, how this applies to data streams is something that we're still thinking through, because people aren't really sharing data streams. They're consuming data streams, but they're not sharing them. And we talked about the FDA regulatory use case. The regulator isn't necessarily at the data stream level, it's more at the derived level. So we thought this was the first place to start.
Curiously, can we, actually I'm kind of curious, would those data streams fall under HIPAA? Can you require people to give them to you?
Does the HIPAA?
So I think regulations saying, if you want this is your patient data, right? If you're a patient, this is your medical data.
Oh, well, I guess, none of this stuff falls under HIPAA,
Right.
because they aren't,
Sure.
they aren't a business agency or whatever, so.
Yeah, I'm just curious.
Other questions?
Yeah, sorry, I came late. The database, what kind of database structure, and is this as an example of an implementation in the actual, when this is launched, right, is it individual providers going to implement it in their own way? Can you
Yeah,
comment?
that's a great question. Yeah, those are both good. So in terms of the database, this is a very lightweight, so this is just a Postgres relational database is the way we implemented it. It's actually fairly lightweight. It's really just managing kind of that connection between the patient identifiers here and sort of the shimmer and identifiers here. And then it's holding a little bit about the application, but it's a very minimal amount of data that's actually being stored here, because it's pretty much pulling live from these APIs all the way through. And so there's not too much there, but our implementation just, I think, uses a Postgres relational database. So it's not sort of a large data store or NoSQL type of store. And then to your question of would each provider implement it independently. So the way that Smart on FHIR application could work, so if people were comfortable with it, for example, in terms of a privacy or security perspective, the health system IT was comfortable, this whole thing could just live as one Amazon instance, and everyone could just point to it. It doesn't have to be distributed, because what's local to the health system is the EHR and the authentication and Smart on FHIR authentication framework. And so that if you registered this application sort of location with that, then it could run and perform all of its work in the cloud and return it to the local version. If for some reason the health system just, from a security privacy perspective, wanted to have a local implementation within the firewall of their own health system, they certainly could stand this up. And all of this, Eric, is this also all just sort of Dockerized and as with everything else?
Yeah, everything you see in that OMH on Fire box is its own individual Docker component. We have we can use Docker Compose to spin everything up, and you can host it within minutes in your own environment.
So it could be stood up independently in the environments as well.
And that's all on GitHub. You can get it,
Yeah,
bring it down, use it tonight. One of the major design features that we really wanted to work through was that there's no data from the EHR, no patient identifiers from the EHR that needs to go to the OMH on Fire server. Everything stays within, so if you think this is UCSF, everything stays within UCSF. The handshake about who that patient is and who that doc is occurs without any, sensitive information leaving, and that's absolutely critical, right? And in fact, if you were gonna build this thing and try and sell it to, a health system, right, the fact that they don't need to send anything outside of their firewalls is really helpful, and yet you have the information you need to know who this information is about, who to send it to, which doc it is. You have, access to all the data that can be out here, and then you can provide, your special expertise or decision support, and it will show up, in front of the clinician's eyeballs. But it's really, really important that we made that distinction there.
Could you explain that just a little bit? Just because I thought at one point you had said that you're linking the unique patient identifier from the EHR to the device of that person. How do you do that?
Yeah. So I do. I did say that, and I think that is the case, that we do keep the ID. There's no additional information now. Whether that ID is their actual patient ID or whether it's a token that's generated, maybe more than.
So on the EHR side, like if this is UCSF would generate a patient token. It's their FHIR token essentially, but it's not the MRN, right? The MRN never leaves UCSF, but the FHIR token is what's used to communicate, and with the FHIR authentication, we know who it is, but really the real person is only resolved at the EHR level. Does that make sense? Yeah.
And this is just for the persistence of the connection. So if you were okay with authenticating each time, you really wouldn't need to maintain any of that data. So in other words, we do it just so they don't have to log in each time to the.
But it's also helpful if you have multiple streams that you're trying to aggregate.
Right. Exactly. Yeah. Keep those all.
Yeah, I think the important thing is to have some kind of a mapping table as part of your FHIR server.
Right.
So you don't really provide any names. It's just tokens and things like that goes into everything that is outside the firewall, including what's on AWS and instances. And then once you aggregate it, it's all based on a token number, right?
Yeah.
That way there's no
These are
information.
tokens also.
Yeah.
They're all tokens.
Makes
Are
sense.
you doing this in a sandbox form at UCSF?
Not yet. It's now at Georgia Tech because that's where the grant is. But happy to stand it up, and we can think about doing a lot of smart on fire work now with Andrew and so forth. So yeah, this can certainly be stood up.
Do you put the user credentials for the devices to generate that token ID?
So
at some point?
when so and I did maybe too quick, but when you click on the page or they go in, or you launch the app, and you say, okay, I want to use Google Fit or Fitbit or whatever, it brings up the authentication username password screen for that device. So so that if I go and I'll try to pick somebody more random to make sure I don't grab some that we've already done, but basically if we pick somebody, maybe this person's thought. So if I link, well, I've already tested all these.
That was the first page. You have to go to page 2 or 3, I think. You have to go further down the list here, but there we go. Okay, the next wasn't there. Okay, so here's someone very random. They should not be
authenticated. So when I click this here, it should ask for my authentication credentials. And it's just because I have cookies that it's listing all of my various Google accounts that I have in my life. But if this weren't there, it would ask for the username and password. So if I, said none of these, use another account. There you go. This would be the way it would typically pop up.
Just to be clear, that's
here.
the patient's user account. They have to
This
give
is the
they have to
patient's-
give you permission to.
And that's
Patient
because
information.
we're linking to Google Fit.
Because we're linking to
If
Google
we did
Fit.
Fitbit, it would look
It would be a
different,
Fitbit screen.
because it would be
Exactly.
Fitbit.
Yeah, they control that authentication screen.
And who gets this information? Like, does the patient themselves go on and provide that information and the doc doesn't know and UCSF doesn't know, but they just entered the credentials and everything's sort of set up? That's one way to do it. There are models. I think it's hard for a lot of patients to just do all this by themselves. And so, one model at Ochsner, for example, down in Louisiana, is they have something called the O-bar, kind of modeled after the Genius bar, where if the doc prescribes you, go get yourself a fitness tracker and you come back in 3 months and we'll see whether you hit 4,000 steps or not. The person goes out the door with a prescription, goes to the O-bar where there are a whole bunch of devices and someone's there helping them set up. And that person can then step them through this process and get everything hooked up, and then they just go home and use their device and everything's set up in the back. So there are multiple ways to go about it. There's the technical piece and then there's sort of the logistics piece of getting patients to enter what they need.
We're also doing, there's also this new thing, some of the device makers are doing there's this like pre-configuration. So you could they give you a little SDK and you can put it inside of your app so that you just turn the device on and then the app on and it's synced. There's none of this authentication flow, which is kind of,
So can you talk a little bit more about like how would that work in this situation? Right?
So
Like,
it wouldn't.
Where would the SDK go in John's, in the?
So you'd have to create a separate app, or there'd be maybe a web app or a mobile app, and you would stick the device code inside of the app, and you would just say turn on, connect device from the app, and then the device is on, you turn it on, and it's connected. There's no entering in a username, a password, or there's none of this information, because it's already been pre-configured for that specific patient, which is kind of, it's a little creepy because there isn't this kind of extra assurance of this little hop, but it's also better for user experience. I don't know, we're finding that's that's what we're finding, but this is still kind of the mode of how everyone does anything. And then you go look at HealthKit with Apple's HealthKit and try to configure it. That's a whole other mess. And how do they configure as well? And authenticate.
Sounds a little like with Omada Health when they ship the scale, it's already pre-configured.
Yeah, exactly.
You just step on it, it just syncs.
It's already on, yeah. So it's all connected to their app ahead of time before. But there's
But
that.
to your identification,
Yeah, they know who it
connected
is.
to your account.
Yeah, exactly. That's a great example of that.
So, I have a question. So, if I understood, there's never a point where you could look at, for your use case, where if you want to correlate, for example, the timing of medication, and then we prescribe blood pressure medication, and then change the type of medication, increase the dosage at another time. You can't overlay that with the blood pressure in this kind of scenario, right? Because that information would be coming from the
Can you go
hospital
back to
system.
the picture? No, go
Oh,
back
you mean
to
to our
this.
image?
Yeah,
Yeah.
here we go. So let's say you're pulling in, I don't know, blood pressure or steps from the device, and you want to correlate something like medication change, right, which is over here. Then, this little smart app needs data from here, so you would need to call the EHR and access that resource,
Okay.
right? And so whether the EHR here exposes that resource for you, if you consume it's probably gonna come out as FHIR, right? So it's gonna be a FHIR resource, and then you can have a choice. Am I gonna pull this out as a FHIR resource and pull out this, blood pressure or steps in a FHIR resource and just use FHIR resources, or do I wanna put it in open? I mean, it's up to you, right? It just depends on your use case. But yeah, you're gonna need to pull something out of here.
Yeah.
And then you can show it.
And there's actually one more important piece which we haven't discussed, but relates to some of that aggregate, you can do calculations here, is that you can write back to FHIR. so that you could insert. You're not going to probably want to insert at the level of observations that we just tried to scroll through, 1,000, 10,000 observations. But if you're going to aggregate, a month or whatever, even the daily level, you can write it back to FHIR, and then this whole thing goes away. The next person who has an application that wants to look at blood pressure and adherence and blah, 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 just goes to the FHIR server, and they just ask for it, and they happen to be getting some data that was produced from this and other data that was produced somewhere else. So that if you write data back to the FHIR server, then you can create other applications that can do things just directly against the data that are available in FHIR.
Of course, a lot of hospitals don't allow the write.
Yes, that's the standard, is to not allow that.
So then but
Yeah.
this allows you to access the workflow without the hospital having to agree to you writing to them.
Right.
They don't have to agree to you putting anything in their database. Their database doesn't get corrupted. No PHI leaves, and so it's very safe for the EHR. And yet it opens up the entire workflow. Like, my eyeballs are open to whatever you can put in front of me in a way that fits within my workflow, right? So I think that's really powerful. And then wrapping in the OpenM Health and FHIR thing together just gives people a lot of options.
Yeah, but you need to have this integrated with the hospital's database, right? Because there's a lot of other patient records, whether it is, I don't know, pick one, HbA1c, cholesterol, this and that, right? All that needs to come together somewhere.
So this application, so say this application, we renamed it to, cardiovascular, this application could request, in addition to going this way and pulling back out, it could also request data back. So this could be a richer application that brought in all types of other data and harmonized them, more broadly, but just also use this same pathway kind of from here over. So you could swap out this application with something totally different that used existing FHIR resources and notes and other things, and also went through the OMH on FHIR web service and all that.
Sure.
It also seems like if it were a research project and you had a research data warehouse, that writing to it would make sense, just what you
Sure.
said, with less challenge than writing to the EHR.
Sure.
But we're trying to do a lot of research by integrating a lot of these sensors, and so it seems like it'd be really helpful for that. You're pausing.
Yeah, no, not at all. So I gave a talk like 4 hours ago at AMIA on something called OMOP on FHIR, which is with OMH on FHIR and OMOP on FHIR. It's been a confusing day, but and OMOP is a clinical data kind of warehouse model,
I see.
but it's the same idea that you could go from FHIR to OMOP. So in terms of writing to clinical data warehouses there and being able to push that, there's some nice mechanisms now that you can go directly and write into those sort of analytic warehouse models. So.
Yeah, I think we should connect more on OpenM Health and OMOP, because I think that makes a lot of sense. And of course, our data warehouse here at UC is in OMOP, will be in OMOP, and to think through how we would be including patient-generated health data in an OMOP research warehouse is clearly on the
So who's
map too.
pushing Open and Health on FHIR? Is that like a standard that will be mandated by?
Do you want to comment on how implementation guides work in the HL7 community when there are,
Oh, the implementation guide, there's nothing mandated here. You create implementation guides to try to provide guidance on specific use cases, this use case in particular, and so that's why the use case. If you want to make it an HL7 standard case, then you have to, demonstrate, that it's, being used and so forth. But no, I don't think we have a mandate at this point to do this. So.
Maybe you're gonna help us. You can help us.
Yeah, I think it's whether
We're trying to expose open health data through FHIR. I think that was our motivation. And,
that's right, yeah. So this work is pretty new. This is funded by an NIH grant. We just finished our first year. I think the question of where it goes from here, the OpenM Health standard, as I said, IEEE standard process is moving along. We're talking to the ONC. We're talking to the FDA, in terms of both the data standard and the metadata standard. I think the HL7 OpenM Health OMH on FHIR, with Eric's great work, we have an implementation guide. It's now out there. What do we do with it? do we, we want to promote it like this, get feedback from people, want people to use it. I'm not sure that mandating things is the way to go. I think, I don't know if anyone else in this room has experience of HL7 and how that community works and how something like this gets traction.
So HL7 isn't a mandating,
Yeah, it doesn't seem like
it's
that.
a standards development organization, so we don't mandate things. That's what the federal and state regulators do, right? So they may come along with a guide they want us to publish so they can point to it in a regulatory scheme.
That was my question, right?
This is not
being
being
driven
point-
by somebody else up there that's.
No, there's no NC driver here, but the idea is we want to build the OMH community, and we want FHIR, we want to expand FHIR into the open mHealth, into the mobile health world too, and I think it's a
Yeah.
good synergy we're just trying to work through
Yeah.
at this point.
And I think maybe this is a little bit early for any agency to be looking at this kind of use case and mandating stuff. I think most institutions are still exploring the whole Smart on FHIR approach and using FHIR APIs, right?
I mean, my question was more to do with, there are some positive aspects to mandate,
Oh, yes.
standpoint of standardization, standpoint
Yes.
of, multiple devices, each one not having its own unique standard, with APIs built into it, that way you can do aggregation, you can do a number of different things that would be meaningful to be from a patient-doctor standpoint. That's where I was going.
Yeah, totally.
This is just a perception question. People are really concerned about the privacy and security around their data from the wearables now that the issues have been raised. So when they hear the term open mHealth, how are you reassuring them that it's still gonna be protected, private, secure, and that they have permissions that they're gonna be granting, et cetera?
Yeah, no, it's a great question, and we did Open mHealth, we were just reminiscing, it's been about 8 years, is that right? 7 years. So when we picked the term then, mHealth was certainly in vogue, I hear mHealth is not in vogue. Yeah, I think one of the main things is Open mHealth is a set of standards for middleware. And so we have to be really careful that Open mHealth is not storing mHealth data and making it open, because that's what it sounds like. So we kind of have to just talk already through that.
Right.
Yeah.
So we should all know the same message.
Yes, we can have talking points.
Well, it's kind of like, Kentucky Fried Chicken is now KFC, so Open mHealth could just be OMA.
Could just be OMA, yes, that's true. That's true. Good point.
But I think we intentionally also we don't deal with a lot of the server stuff and hosting because of the privacy and security aspect of things, so we leave people who in the community whoever wants to use the tools in the standard, they can do it on their own and abide by their own privacy and security. So if you're in Europe and want to use Shimmer and the standard, you can deal with all that privacy and security rules over there, or HIPAA in the United States and GDPR in Europe. So yeah, we leave it open to anyone to use it in any fashion they want.
Just in terms of the handing off, it's encrypted and, all those.
We don't handle
those-
encryption.
Okay.
Because that would be handled by the person, whoever's hosting it, and wherever the data is being transported. All Shimmer does is just a mapping. So it's a mapping between Fitbit and the Open mHealth schema. So it has all the kind of tools to help you do that, and allows you to do the permissions that we just shared on Google Fit. But everything else, if you're gonna move it to the cloud or move it around, that's on you to kind of figure out. Your organization or institution to kind of figure that out.
And that was very deliberate, to
Very
leave all the
deliberate, yeah.
implementation pieces outside of what Open mHealth does, so that as you implement, you're responsible for all the security, all the privacy, all that stuff. That's not what we do.
And if there's a breach at, iHealth or Fitbit, we're not really responsible for that either. So that's but yeah, that could happen too.
And how do you keep up with all the upgrading, or how does that affect your, because each one of them.
Yeah, thankfully, they don't really tell you when they're gonna update. There's not a lot of documentation when they're gonna update, but they don't actually update that much. iHealth, for example, Moves told us that they got bought by Fitbit Facebook a couple of years ago. And they just told us in June, I remember, didn't you remember this, like June? They said by the end of June, we're done, we're out. Like and so we had to transform that. So iHealth is a bit of it's a interesting character in terms of their API, but they usually don't change it that often. Maybe like once a year they'll play a little game with us. But once it happens, then we update it.
So we, people are using it enough that we know that the shim is broken and then we
Yeah.
go and fix it. I think we're still, building out the community. We'd like people to just add shims to maybe a blood pressure device or a blood glucose device, to build that community. So going back to what David was saying earlier, if you know anybody who wants to be a community manager, help out or, just let us know. We definitely
Yeah, we could use
want to
the
build
help.
the community more.
Yeah.
Great.
You want to stay in touch with what you guys are doing, is there like an email?
Yes, there
Yeah,
is.
just
So-
go to
yes, sir.
openuphealth.org. There's a mailing list. You
Yeah,
just sign up
sign
there.
up.
Sign up to that?
Yep.
Yeah, and you can go down the path. There's some good content on there on about this world and mobile health in general. So yeah. feel
Yeah,
free
and if
to-
you want to join our IEEE working group, you can
Yeah.
do that as well. Because we're working through the schemas, we're validating sleep and also physical activity, and we're working through metadata, so
So you're
right down into the
focused on
content.
physical activity, the generic physical activity?
Physical activity
schema?
and mobility is one subgroup,
Okay.
and the other one is sleep.
And what specific schemas are you looking at in
In
physical activity?
Simona?
Hi, Anna. We are looking at step count and more generic physical activity, but we're also looking now at use cases that are more that cover specific requirements for people that have that are mobility impaired, to make sure that we're also looking at other measures, not just physical activity. So that's what we're looking at right now.
Yeah, I want to get away from people who are running marathons,
Yeah,
looking at people who have like neurologic conditions or
Yeah.
impaired mobility.
yeah, so what kind of measures make sense if a person is on a wheelchair or is recovering from a surgery, and how do you measure mobility? So that's what we're looking at right
A little
now.
more clinical.
Besides,
It's a lot more clinical.
updating our step count, current step count schema, for example, with the addition of MAT, and also the generic, we have a generic schema for physical activity that covers some information on, because you can't have, basically, the idea is you cannot have one schema for each kind of physical activity. That's just a little bit too much. So we have a generic physical activity schema that in which you say what is the physical activity, and then some information about that that physical activity, which currently we're looking at to see whether there's additional information that is useful. But because we didn't talk about it right now, but there's this idea of how you balance, covering as much as possible with proliferation of schemas that are very specific, and physical activity is a great example. So, because of course every kind of physical activity has its own requirements, but we are looking at this specific use cases for people with that have mobility impairments, to see whether there are special measures for them that might be of use.
Yeah, we're always balancing
Yeah.
how to be full-featured versus, lightweight, and, it's a very pragmatic choice so far. And, so far I think we've made the right choices, but, it's up to the community together to sort of keep making these choices as we go. There's still more food out there, I'm sure.
Yeah, there's still
Right.
more food. And if you end up doing anything with like Shimmer, or want to play with the OMH on FHIR reference implementation guide, let us know.
Yeah.
We'd love to. We can host it on the blog. We can do a blog post about it. We can even do another meetup to bring more community to kind of. We'd like to do show and tells as well. We're
Yeah,
always
yeah.
encouraging that. So
Yeah, use
please
it and,
use it.
show us.
Yeah, people have been playing around with it. You see on our YouTube, you can see how other people have played around with it. So if you have something interesting you want to do and show, yeah, we'll help. We'll work with you on it. But thank you so
Thank you.
much. Please
Yeah.
enjoy more food, and thanks to
Thanks for
our
coming.
special guests as well. So thanks
Yes,
for coming
thank you.
all this way, and this has been great.
Great,
Thank you.
thanks.
Nice to see you again. So soon.
So nice to meet you finally.
Isn't